video, here is a nice problem that was suggested by viewer. Here is the following statement. Determine all real numbers satisfy this following statement. We have n to the fourth minus n cubed plus 2 times n squared plus 9 is a perfect square. Okay, so this one, the way this one was constructed. So this one, if I'm going to try to factor out this one on the form of the quantity square, I will have a problem here due to this coefficient. Okay, as we try to this, because this one is going to be transferred as n square minus n plus something quantity square. But the problem, we try to expand this one out, you get 2 times n cubed. But the problem, we don't have the 2 times n cubed. Now we are going to fix this one by applying, if you have x as a perfect square, also this one is going to multiply by q square is multiplied by x is a perfect square. We're going to apply this one here. So which number is convenient to construct a perfect square here? Number 4, because number 4 will be transferred as 2n square minus, and this one is going to be 4n to the fourth minus 4n cubed plus 8n square plus 36. This one is going to be transferred as 2n square minus n plus something quantity square. Okay, which is good to go. Okay, going to transfer this one into inequality. Let's call this one as a capital A. Okay, so we have this capital A as a perfect square. It will be between two squares. Okay, so this one will be as 2n square minus n plus another number which is a quantity square is strictly inferior than a is strictly inferior than another term 2n square minus n plus b quantity square. Okay, so we have a perfect square between two perfect squares. So now we are going to determine this value a and b. So in order to do that, I'm going to expand this one out and make the comparison between the coefficient of this one and coefficient of this one by matching number by number. Okay, so this one, as I'm expand this one out, 4n to the fourth minus 4 times n cubed plus n squared plus 2 times this one which is 2a is multiplied by 2n square minus n plus the last term which is a square. So what I have done here is just I put in this one together and I square it and expand this one out. It came up with this expression with these three terms. Then plus 2 times of 2a is multiplied by this quantity here which I got here plus the last term which is a square. Okay, then this one will be compared with this a. A will be written as this one, which is strictly inferior than this one. So we have to work on this one first, then we'll move on to the next one. Okay, so it seems here I have a lot of stuff going to cancel out here, which is this one and this one, this one and this one, because both terms are the same. Okay, so the only thing left, this one and these two terms. So this one is going to be written as 4a plus number 1 is multiplied by n squared minus 2 times an plus a squared is strictly inferior than these two terms, which is 8n squared plus 36 is strictly inferior than this term which is coming up. So we'll have the same thing for the second inequality. Instead to put a, I'm going to put b. Okay, so we'll have 4b plus number 1 is multiplied by n squared minus 2 times bn plus b squared. Okay, now we are going to make the comparison just this one and this one and this one. Okay, so we are going to ignore the other stuff because the most powerful term which we are going to compare just this coefficient and this coefficient. This one is not a variable because this one was cancelled out from this one, so we don't have to make the comparison with this one. So And also this number a square, we are going to ignore this one because they are just a constant. So we are going to make comparison by this one and this one to guess where we have inequality occurred. Okay, so which means I will have 4a plus number 1 is strictly inferior than 8 is strictly inferior than 4b plus number 1. So my comparison is going to be checked here. Okay, so by guessing, by giving a equals 1, by guessing if I'm going to give a equals 2, will be impossible because I have 9 is strictly inferior than a, which is impossible. So which means this one is telling us a must be tick number 1 here. Also, if I'm going to make to stay in the safe spot, to be this one guarantee this one bigger than this one, I'm going to go a little far away from this 8 by giving b equals 5. Okay, if I'm going to b equals 5, I get here 20 plus 1, which is 21 is strictly inferior than 21. Also, if I'm going to just give b equals 3, I get 13, which is okay for this inequality. But the problem when you make the comparison between the whole number and this one, you will have a problem. You will have this inequality is not verified in this condition because we made just a comparison between just the big coefficient where we have. So because we made just the comparison just for the coefficient, which is this one, we don't have the comparison between other terms to decide exactly which is the right value of b. So now we are just guessing. Okay, by this guessing we are going to make this comparison to check this one and this one are satisfied this inequality. So I'm going to tick this value at the top and continue solving our equation. And now previously we were working on this inequality. By guessing we found out these values and replaced AB with number 1 and 5. Now we are going to make the comparison between this term and this term to check the number that we have is satisfy this inequality or not. Okay, so now I'm going to, by doing that, I'm simply going to expand this one as I did previously. So I will have 4n to the fourth minus 4n cubed plus n squared plus 2 times this term, which is 2n squared minus n, plus the last term, which is number 1 is strictly inferior than this term. I'm going to rewrite this inequality as it was, like 4n to the fourth minus 3n cubed plus 8n squared plus 36 is strictly inferior than this term. Okay, we will have too many things is going to cancel out here, this one and this one, because they are the same. So the only thing left, I get here 4n squared plus n squared, which is 5n squared minus 2n plus number 1 is strictly inferior than 8n squared plus 36. Okay, so this 5n squared will be cancelled down to the 3n squared. This number 1 be cancelled out with down to the 35. By taking all the numbers to one side, I get here 8n squared plus 2n plus 35 is strictly superior than 0. So the only thing left for this inequality to check this one is bigger than 0. This one, of course, this one is a bigger than 0 because this term is bigger than this term, whatever the value of n. Even if you replace this one with negative values, you still have this one bigger than this one. Okay, because quadratic form is growing quickly than linear form. Okay, so which means this inequality is verified this condition, which means this one is strictly inferior than this one. Now the only thing left, this one and this one, we have to make the comparison between this term and this term. So I'm simply going to rewrite this one as it was here. Get 4n to the fourth minus 3n cubed plus 8n squared plus 36 is strictly inferior than this one. So I'm going to do the same thing by expanding this one out. I get here 4n to the fourth minus 4n cubed plus n squared plus 2 times 5, which is 10, is multiplied by 2n squared minus n plus 25, 5 squared. Okay, so we'll have a lot of stuff cancelled out as I did previously, this one and this one. by taking all the stuff to one side. This one is multiplied by this one, I get 20n squared plus n squared, which is 21n squared. By moving over this 8n squared, I get 13n squared. By taking all these objects to one side, okay? Then minus this term, which is minus 10n, plus 25 minus 36, which is minus 11, is strictly superior than 0. Now I'm going to move over these two terms to the right. I get here 13n square, strictly superior than 10n plus 11. Now we are going to make the comparison between this term and this term. Which condition is make this inequality holds? If I'm going to give n equals 1, it's impossible this inequality will be held, because I will have 13 is strictly superior than 21, which is impossible. If I'm going to give n equals 2, I get here 4 is multiplied by 13, which is 52. Okay, 52, by replacing n with number 2, I get 20 plus 11, 31. 52 is bigger than 31, which is correct. So this inequality holds for all n is superior to 2. Okay, we are not going to talk about the negative numbers, because this one of course is bigger than this one if n is negative. So now we are talking about the positive. So this is the condition to verify this one. So which means our inequality satisfied this condition when we took b equals 5. Okay, I'm going to erase this board and continue on this one. Previously we have constructed this inequality and came up with this nice results. Now we found these values a and b, found 1 and 5. Now inequality is in a good condition. Now we are going to find a solution for this inequality. If you take a look here, so the distance between this one and this one, I'm going to pick up the such values of this perfect square, because we know this perfect square is located between two terms. These two terms are the same, so which means this one is going to take the number after this capital A, which equals 4n to the fourth minus 4n cubed plus 8n squared plus 36 is going to take the number coming after this one, which is 2n squared minus n plus number 2 quantity square. We are not taking this one itself because this one is strictly inferior than a. We are going to take the number of coming after. Okay, even though we are working on the real numbers, but we are dealing with the natural numbers for this one, because we have these numbers are the natural numbers. Okay, so I'm going to add this one. We have a and b are the natural numbers. Okay, so I'm going to expand this one out and get here same thing, 4n fourth minus 4n cubed plus n squared plus 4 times is multiplied by 2n squared minus n plus number 4. Okay, so this one will be cancelled out with this one will be cancelled out with this one. Also this 8n squared will be cancelled out with this 8n squared, left with n squared, because this 8n squared will be cancelled, is already cancelled out with this 8n squared, plus minus 4n plus number 4. By taking all the terms to one side, I get here n squared minus 4n, so I get here minus 32 equals 0. Okay, so I'm going to use a trick here in order to factor this one out. I get here n minus 2 quantity squared, I get here n squared minus 4n plus number 4 minus 36, which is equals to 36. Okay, this 36 is the same as 6 squared. I'm going to factor out this one. I get n minus 2 minus 6 factor n minus 2 plus number 6 equals 0. Equivalent, this one is given as n minus 8, so we'll have n equals 8 is a solution, or n, so here I get n plus 4, which is n plus 4 equals 0, which is n equals minus 4. So this one is a first solution. So I'm going to tick this solution up here. Now I'm going to check another possibility. Now the second possibility, I will have 2n square minus n plus number 3 quantity square equals, by doing the same thing here, I get here 4n to the fourth minus 4n cubed plus n square plus this one is multiplied by this one, which is 6 is multiplied by 2n square minus n plus 9 equals 4n to the fourth minus 4n cubed plus 8n square plus 36. Okay, so we'll have too many stuffs are going to cancel out, this one and this one, so I will be left with 5n square. You get here 9 minus this 36 here minus 27 equals 0. Okay, by using the delta here, I get here 6 square, which is 36 minus 4 times 5 is multiplied by minus 27. If we check this one, we get here 24 quantity square. Okay, so square root of delta is 24. So the solutions, I will have n 3, I will have 6 plus 24 over 10. The second solution, I will have n4 6 minus 24 over 10. This one is given us 624, which is 30 over 3, which is 3. This one is given us minus 24 minus 18 over 10, which is minus 9 over 5. Okay, plug in both numbers as a real numbers into this one is given as a perfect square. Even though we have this fraction, when you replace this one into here, you get something like, you get 7,649 over 6,561, which is going to be written on the form 141 quantity square over 25 quantity square, like this. Okay, which is a perfect square. Now we'll have the following solutions. I get n3 equals 3 and n4 equals minus 9 over 5. Let's move on to the last case. For the last case, I'm going to switch this one to number 4. So I'm going to do the same thing. I get here 4n to the fourth equals to 4n to the fourth minus 4n cubed plus 36. Okay, making the comparison between the left and the right hand side of this equation, I get here too many things going to cancel out, so I will be left with, I get here 17n square minus 8, which is 9n square, 9 minus 8n minus 20 equals 0. Now by calculating delta of this one, I get 64 h square minus 4 times is multiplied by 9 is multiplied by minus 20. Calculating this delta, we get here 784, which is the same as 28 quantity square. Okay, by taking the solution for this one, I get here n5 equals 8 plus 28 over 18, and the second solution, I get here 8 minus 28 over 18. This one I get 8 plus 28, which is 36 over 18, which is 2. This one is giving us minus 20 over 18, which is minus 10 over 9. Okay, this is not a perfect square. When you check this one, when you plug this term into this one, is not going to give us a perfect square. Okay, but this one is still working. This one is giving us a perfect square. Okay, so I'm going to add only one solution from these solutions. I get n5 equals number 2. So we get 5 solutions are satisfied this equation. I have done with this problem. If you have any question regarding this problem, just put it in the comment section below. If you have any question or suggestion, just put it in the comment section below as well. So by the way, don't forget to support us with a like and subscribe. Thank you for watching. I will see you next video. Bye.